Find and classify all points of inflection. Inflection means f double prime of x equals 0. We need to figure out the second derivative of this function. F prime of x equals, use the power rule, negative 12x to the third power minus 24x squared. F double prime of x equals negative 36x squared minus 48x. Common factor, negative 12x. 3x plus 4. Then we will draw the sign diagram for second derivative. Roots. x1 equals 0, x2 equals negative 4 over 3. Sign diagram for f double prime of x, negative 4 over 3, 0. Let's use 1 as the number to test. F double prime of 1 is negative, positive, negative, because these are single powers. So we need to change the sign. There is a sign change at negative 4 over 3 and at x equals 0, which means concavity changes at x equals negative 4 over 3 and x equals 0. So, point of inflection at x equals negative 4 over 3 and x equals 0. Let's go to guided practice 7. Given function f of x, find and classify all stationary points and points of inflection. For A, we will figure out the first derivative and second derivative. Use the power rule. We got 6x squared minus 6x minus 36. Second derivative equals, still power rule, 12x minus 6. We will set up the first derivative equals 0 for stationary point. 6x squared minus 6x minus 36 equals 0. Divided by 6 both sides. X squared minus x minus 6 equals 0. Factor. Then x1 equals 3, x2 equals negative 2. Sign diagram. For f prime of x, negative 2, 3. The number for test is 0. We plug back in to this first derivative function. We got negative, because these are single powers. So we need to change the sign. Increasing, then decreasing. So we know at x equals negative 2, there is a local maximum. Decreasing, then increasing. At x equals 3, there is a local minimum. We can use this sign diagram to figure out increasing or decreasing intervals. F of x is increasing on the interval negative infinity to negative 2, union 3 to positive infinity. F of x is decreasing on the interval from negative 2 to 3. We will make second derivative equals 0 for point of inflection. 12x minus 6 equals 0. So x equals 1/2. Let's draw this sign diagram. 1/2. 1 is a positive. Here is a negative. Since there is a sign change at 1/2, so point of inflection at x equals 1/2. Concave up or down using this sign diagram. Concave down on the interval negative infinity to 1/2. Concave up on the interval 1/2 to positive infinity. Sketch this graph, clearly showing stationary points and a point of inflection. F of -2, we plug into the original function. F of 3 equals -74. F of 1/2, -11.5. Local maximum point. This is a local minimum point. And this is a point of inflection. Label x, y, origin. For x, we will label as 1, 2, 3. -1, -2. For y, you could say -74, 10 as the scale. Label, this is a positive 10, here is a -10. Then get these 3 points. -2, 51. 3, -74. 1/2, -11.5. Increasing graph from negative infinity to -2. 0.7 is y-intercept. So get a point here. Just estimate. Point of inflection. So change the concavity here. This is what the graph look like.